Greetings, judges from Geniuos Olympiad. My name is Đặng Kim Sơn and I'm a 10th grader from Wellspring International Saigon School. And my partner is...
Greetings, my name is Dương Thị Quỳnh Như and I am a 11th grader from Gia Định School. A few years ago, my mom told me that we have to visit a relative of mine who have lung cancer. After seeing her in immense pain and suffering, it became clear to me that I have to contribute to the cause of curing or at least helping those that have cancer.
And according to WHO, cancer is the second leading cause of death. In 2018, 18 million people are diagnosed with cancer and 9.6 million people have died from cancer. And in Vietnam alone, over 165,000 patients are diagnosed with cancer. So I personally feel responsible to contribute to the cause as well.
Also, there are various reasons causing free radicals in our daily life. These radicals can contribute to cause chronic health problems such as cataract and cancer. Therefore, we have decided that we will research the anti-cancer and oxidation properties of local plants and vegetables. And what did we find, Sean?
After researching Eastern medicine and traditional medicine of Vietnam, we have found that a particular plant, black ginger, even though are reported to have anti-cancer and anti-oxidation properties, although there are 683 studies and 7 scientific research into this herb, there has not been any research into its anti-cancer and oxidation ability. Because of it being local to Vietnam and easily extracted, we figure that if we can prove its ability in treating cancer and prevent oxidation, it can help Vietnam patients tremendously. Therefore, our group project name is Research on Biological Activity of Kaempferia parviflora.
Let's begin the method part. In proving black ginger anti-cancer and oxidation properties, we first have to choose the solution to diffuse the solute in. After careful consideration, we make 3 different black ginger extracts: ethylene extract, acetic acetate extract, and infusion extract. And what method we use to make this extract, Sean?
In order to obtain the ethyl acetate extract, we wash and dry black ginger tuber at 50 degrees Celsius until the mass of the sample was unchanged. Then we take 100 grams of the tubers and crush it into powder. After that, we soak it in ethyl acetate solution with the rate of 1 to 10 grams per milliliter for 48 hours. Thirdly, filter the sample to obtain an extract. The last step is preserving the extract in a refrigerator at 4 degrees Celsius to use in experiments. After obtaining the extract, we then have to prove its anti-cancer and anti-oxidation properties. Firstly, in order to prove its anti-oxidation property, we have to use the DPPH free radical method. So, Như, can you introduce us about this method?
Sure, why not? DPPH is developed by Ploys in 1958. DPPH is a method for measuring the oxidation resistance of the test sample. This operates on the principle that the free electrons of the nitrogen atoms in DPPH will decrease if the sample has antioxidant activity, giving hydrogen to neutralize free electrons, reducing absorption at maximum wavelength, and the color of the reaction solution fades, changing from purple to light yellow and vice versa.
DPPH shows strong absorption at the 557 nanometer wavelength. The important about this method is the lower value of the OD optical density indicates a higher DPPH root capture capacity. Như, can you share with our judge why we decided to use this method, even though that it has its own disadvantage, like it may not give the outcome as accurately as other complicated methods?
Yes, I'm willing to share the reason for our decision. DPPH is considered to be a simple, easy to follow method to determine the antioxidant activity of a sample compared to other scientific methods. For that reason, it becomes a suitable method for high school students. In order to make the answer become more accurate, we try our best to be careful during doing the research.
After finding out its IC50 value of antioxidation, we then have to find the IC50 value of its anti-cancer properties, which we will use the Monk's method. The Monk method is approved by the National Cancer Institute.
Now let's move to the results and discussion part. The table here shows the efficiency of the three solutes. After extraction, the ethanol extract of Kaempferia parviflora roots was recovered with an efficiency of 5.8%, achieving the highest efficiency. Ethylene acetate extract of black ginger was recovered with an efficiency of 4.5%, and the effusion extract was recovered with an efficiency of 3.8%. Through this table, we found that when the concentration increased from 31.25 to 500 micro per milliliter, the percentage of DPPH free radical activity of infusion extract also increased. This proved that the antioxidant capacity of the infusion extract of the black ginger is proportional to the increase of the concentration.
From this, we can construct a linear equation. With the above equation, we can determine the IC50 value of the PPH free radical trap of the black ginger infusion was 196.41 nanogram per liter.
The table over here is the DPPH free radical capture activity of black ginger acetic acetate extract. Through table, we found that when the concentration increased from 31.25 to 500 microgram per milliliter, the percentage of DPPH free radical activity of ethylene acetate extract also increased. This showed that the oxidation resistance of the ethylene acetate extract of black ginger is also proportional to the increase in concentration. From this, we can construct a linear equation here. With the above equation, we determine the IC50 value of DPPH free radical trap of the black ginger acetic acetate extract is 196.41 microgram per milliliters.
Next, the table here shows the efficiency of DPPH free radical capture activity of black ginger ethanol extract. Through the table here, we found that when the concentration gradually increased from 31.25 to 500 nanogram per milliliter, the percentage of the PPH free radical activity of the ethanol extract also increased. This showed that the oxidation resistance of ethanol extract of black ginger is proportionate to the increase in the concentration. With the above equation, we can determine the IC50 value of the PPH free radical trap of black ginger ethanol extract is 196.41 microgram per milliliters.
Here is a table about the IC50 of three extracts. We found that all three extracts of black ginger have antioxidant activity and is proportional to the concentration of extract. Combined with the table here, we can see that ethanol extract have higher resistance to oxidation than ethylene acetate extract and infusion extract at all test concentrations.
In this table, we have compared the ability of free radical capture of black ginger with other herbs which have been already researched and used. Through the table, we can see that black ginger DPPH free radical activity trap is above every different herbs. Through this three table, we have seen that all three extracts of black ginger are capable of causing toxicity to lung cancer cell, but not toxic to the fibroblasts. Among three types of extract, ethanol extract has the highest ability to cause toxicity to cancer cell, 66.99%, followed by extract of ethyl acetate at 40.15%, and infusion extract has the lowest toxicity to cancer cell at 33.78%.
However, infusion extract is safer for fibroblasts, minus 24.48%, than with the two remaining extracts. Ethyl acetate is minus 12.60% and ethanol is minus 7.82%. From the above results, we can exploit the anti-cancer potential from the black ginger tuber.
In conclusion, black ginger has the ability to kill cancer cells and prevent oxidation effectively. However, ethanol extract has the highest efficiency with 5.8%. It also is the most effective in resisting oxidation as 134.54 microgram per milliliter, and it also has the strongest toxic activity with 66.99% to the cancer cell.
For that reason, black ginger deserves a place in scientific medical research. It is crucial to have the development into food functional drugs. I would say without a doubt that we will do more research on the ability to capture free angle anti-cancer of tubers in Geniuos family with a complicated method so as to give a more accurate result.
That is the end of our presentation. I hope you enjoy it and thanks for listening.